Hi, this is Dr. John Bergdorf. This video is meant to be a summary of techniques for factoring polynomials. So ideally, you would look at this video after you have finished a chapter in your algebra book in which you're shown a variety of different techniques for factoring polynomials. And after having practiced these different techniques as you've had them introduced to you one at a time, and you're about the end of the chapter, the question you have to ask yourself is, how do I decide which one of these techniques I should use if I randomly see a polynomial, let's say on like a test? There's so many different techniques. How do you know which one to use best? So this first sheet that I have for you here is a summary of all the major techniques used for factoring polynomials as they're generally taught in a college algebra class or an intermediate algebra class. You may want to take a screenshot of this page or a picture with your phone, or slow the video down and in the old-fashioned way handwrite a copy of this. Something that you can hang on to not only as you go through the rest of this video, but as you practice for your test. Now the way this video is going to work is we're going to take a minute to talk through these different techniques. And then I have 4 examples. And what I'm going to do is when we get to an example, I'm going to show it to you, and then I'm going to ask you to stop the video, and using this guideline, you try to figure out how to factor it. And once you think you've got it, then start the video back up and we'll work it together. And together we'll see if we're getting the same answer. And hopefully that'll be a wonderful way to practice with the decision-making process of how to choose a technique for factoring polynomials. So again, maybe while I'm talking, make a screenshot or a photograph of this page, and we'll just kind of talk through it a little bit. So when you are faced with a random polynomial and asked to factor it, what should you do? Step number 1 should always be this. Look to see if there is a common factor among the terms and factor that out first. Oftentimes you can still factor the polynomial if you don't do this first, but the numbers involved will tend to be more difficult and the different techniques will be harder to choose from. So do that first. Once you have done that, what you do next will depend on how many terms the polynomial has. So this sort of classifies or sorts the different methods based on the number of terms. So let's suppose first that you are faced with a polynomial with 2 terms. If you have a polynomial with 2 terms, the major ways to factor that are by basically using 3 formulas as sort of like templates. You ask yourself whether the polynomial you're given fits into one of these 2 forms. Is it 1 square minus another? Is it 1 cube minus another? Is it 1 cube plus another? Now, you might remember that a sum of 2 squares will not factor at all using only real numbers as coefficients, so we say that that one is prime. But if you can identify a sum or a difference of cubes or a difference of squares, and you can identify who the A and the B are, then you basically just plug into these templates as if they were like formulas. So that's what you do if you have 2 terms. Now, if the polynomial has 3 terms, you probably want to start first by asking whether a certain template would work there as well. You want to ask, could this trinomial be a perfect square trinomial? And that will happen if the first and last terms are both happen to be perfect squares, and whatever it is that's squared at the first and whatever it is that's squared at the end, the term in the middle has to be 2 times the product of those 2 quantities. That's true whether there's a plus sign right here or a minus sign right here. The only difference is where the plus or the minus goes in the formula. Either one of those will factor as a binomial squared, a perfect square trinomial. Now, if your polynomial happens not to have 2 perfect squares in it, then you have to use either a trial and error method or an AC method, or one of the many, many variants on those two methods, and see which one of those would work. And that gets to be your choice based on what your preferences are. Finally, if the polynomial has 4 or more terms, then the only method really available is grouping. And so you make your decision based on whether your polynomial has 2, 3, or 4 or more terms. Now, if you survive this far, and hopefully you do, and hopefully you do so quite happily, you might be tempted to celebrate, but you want to pay attention to step number 3 as well. You want to continue to factor until every factor is prime. You may see that you could factor one of your polynomials farther, and you do want to do that. Don't stop until you're sure that every polynomial cannot be factored anymore. Okay, that's pretty fast, and you probably have spent a couple weeks learning all these different techniques. That's just to give you kind of a brief rundown. What we're now going to do is look at the first of our sample polynomials, and using the guidelines that I've shown you so far, take a minute or two and see if you can factor this one. So I'm going to suggest that you pause the pause the video when I say now, and then restart it once you think you've got the answer. So pause your video now. All right, hopefully you have successfully factored that. Let's see what you did, and let's see how to do this. So, first of all, remember that the first step is always to look for a common factor first. This has one. If you look at the two coefficients, the 12 and the 27, you might notice that they're both divisible by 3, so you can factor out a 3. But also, both factors have both a factor of x and a factor of y in common. You want to factor out that entire common factor. So that would look something like this. You factor out the 3, you factor out an x, you factor out a y, and then you ask yourself what's left. 3xy times what would give me the 12x cubed y squared? Well, 3 times 4 would give you 12, and you'd also need an x squared to get to the x cubed factor. The y is completely factored out. 3 times what gives me 27? That would be a 9. 3 times 9 is 27. You factor out an x and a y, but notice you'd still have a y squared. Now, you have basically done some factoring, but should you stop right here, this actually gets to the third point on my previous page. You don't want to stop factoring until you're sure that every polynomial is prime. And the deal here is, if you look at the remaining 2-term polynomial, you might recognize that it is a difference of squares. This first term is 2x squared, and the final term is 3y squared, and it's one square minus another. This would act like your a and your b in the formula, and a difference of squares factors is a plus b, a minus b. Here's what that would look like altogether. 3xy, a plus b, I'm writing what I'm meaning by a and b, and a minus b. So 3xy times 2x plus 3y times 2x minus 3y. Now you know this can't factor any further because these are 2-term polynomials. Neither one of them is a difference of squares. You've gone as far as you can go. Factored completely. How'd you do? Hope you got it right. Let's try another one. So look at this one, and again, when I say now, pause the video and give it a try, and then come back when you're ready. Now. All right, let's jump into this one. So again, the first thing you want to do is you want to ask yourself, is there a common factor between all these terms? And I think you'll see that there is not. So then you say, okay, it's a 3-term polynomial. Could this possibly be, the first thing to look for, a perfect square trinomial? For that to be true, the first term has to be a perfect square, and so does the last term. Or maybe they'll be shuffled around, but 2 of the terms have to be perfect squares. Now you're good on the a. A squared is a squared. But what about the 6? Is 6 a perfect square? And you realize it's not. And in fact, neither is the 5 on the end. So this is not a perfect square trinomial. And if you have a 3-term polynomial that's not a perfect square trinomial, your choices are to use some sort of trial and error method or the AC method. I think what I'll do is I'll work it twice. I'll work it both ways. So depending on which method you like best, you'll get to see your method. I'm going to start with the trial and error method. Now, what is that? A trial and error method for solving a 3-term polynomial basically says that if a trinomial does factor, it would have to factor into 2 binomials. And to get the variables that you want, you would need an a in each binomial to end up with the a squared, and you need a b in each binomial to end up with the b squared. So this would give you something a squared plus something ab plus something b squared. Now these blanks represent numbers, and you have to choose those, and basically by guessing. But it's not a complete and total guess. These 2 numbers here, which is how you would get the a times the a or the a squared, the 2 coefficients would have to multiply together to give you a 6, that leading coefficient. So you're looking for 2 numbers whose product is 6. These 2 numbers, by contrast, those numbers are going to get you the coefficient of the b squared term. So in these blanks, I'm looking for 2 numbers whose product is -5. Now you guess. So product of 6. There's a bunch of things you could put in these 2 blanks. It could be, for example, 6 and 1. That gives you a product of 6. Or it could be 2 and 3. Now, you might try a number of things and not get the right answer right away. And that's totally fine. That's nothing to worry about. But I'm hoping that at some point as you try different things, you realize that it would work really well if you put a 3 here. Oh, let's stay color coordinated. Oh, no, we'll stay color opposite. A 3 here and a 2 there. That gives you a product of 6. And to get a product of -5, it turns out to be pretty nice if you put a 5 here and a -1 here. So yes, the numbers in the blank can be negative. That's why I just put a plus sign. Either way, I could use negatives. Now, it's very possible that you did a trial and error and basically had these 2 factors reversed with the 2a plus -1b first and the 3a plus 5b second. That's fine. Commutative law says you can do that. No big deal. The way you know whether you're right or not is you use the FOIL rule and multiply these back out and see whether you get the original polynomial. And if you'd like to save a little bit of time, because you chose the numbers in the blanks to get the correct first and last terms, you really only have to check the O and the I terms from FOIL. I call this checking the OI, the outer and the inner terms. That's really all you have to look at. So if you look at the product of the outer terms, that's this one and this one, that would give you -3ab. And then if you look at the product of the inner terms, that's this one and this one, that would give you 10ab. -3ab plus 10ab happens to give you 7ab. That's what you want. You want to get the right middle term. And if you do, then that tells you that you have factored this correctly. Now, I've got this all marked up and messy and so forth, so it might be nice to recopy things without the blanks. And instead of plus and negative, I'll say just subtraction. 3a plus 5b, 2a minus b. That's how it factors, using the trial and error method. Let's suppose that rather than the trial and error method, you prefer the AC method. So let's work it again in case you did it that way. I'm going to just clear out all my ink here and start all over and talk about the AC method. So the A and the C refer to the first and last coefficients of your trinomial. And what you do is you multiply those together. So 6 times -5 equals -30. And what you're looking for is 2 factors that would give you a product of that negative 30, but also would give you a sum, when you add the two factors together, of the middle coefficient. That's what you're aiming for. Two numbers whose product is negative 30, but whose sum, in this case, would be 7. And you try a bunch of things, and again, there's an element of trial and error here too, and you may make the wrong choice at first, and that's okay. So an example of what you could choose would be, say, 15 and negative 2, because that gives you a product of negative 30. But you ask yourself, is 15 plus negative 2, is that equal to 7? No, it's equal to 13. That's the wrong one. So that's not the right choice, but you just make a different choice. And it turns out the one that works would be if you choose a 10 and a negative 3. And again, if you have that in the other order, it doesn't matter. 10 plus negative 3 is 7. That's what you want. So what do you do with these crazy numbers? Well, what you do with those numbers is you use those numbers to split the middle term and create, from the 3-term polynomial, a 4-term polynomial. So that would look like this. You would have the 6a squared, no change there, but instead of the 7ab, split that into 10ab minus 3ab, and then go ahead and leave the last term as it is. 6a squared plus 10ab minus 3ab minus 5b squared. Now, because it has 4 terms, we remember that 4-term polynomials are factored by grouping, and you do that. You use grouping. Group the first 2 terms and ask yourself, is there just a common factor between those terms? And I think there is. If you look closely, 2 goes into both 6 and 10, and there's an a in both factors, so I believe I could write that as 2, factor out a 2a, and I would be left with a 3a and a 5b, because 2a times 3a is 6a squared, and 2a times 5b is 10ab. Now looking at the last pair of terms, I don't see a coefficient in common, but they both terms do have a b in common. And when this middle sign is a negative, like it is here, it's often good to factor out a negative common factor. That's more likely to give you the match you're looking for. So I am going to factor out from the second pair a negative b. And what would that leave me with? A positive 3a and a positive 5b. Because negative b times 3a is negative 3ab, and negative b times 5b is negative 5b squared. Now, what you're hoping for and what we got, and that's really wonderful, is what we call a common binomial factor. So notice that both of these terms contain a 3a plus 5b. That's a common factor. And as a common factor, you can factor it out. So I'm factoring out the common factor that I've underlined in green. And what I'd be left with is whatever remains from the first term and whatever remains from the second term. 3a plus 5b times 2a minus b. And again, you may get that in the reverse order, but if you check back, that's the exact same answer we got the other way by trial and error. Your choice, whichever of these methods works best for you. All right, example 3. Take a look at this. When I say now, pause the video and then you try it. So now. All right, let's get back together on this one. So this one, in a way, kind of what we showed with the AC method in the previous example, gives this one away. When you have 4 terms, you really have to use grouping. That's about all you have. So you group the first 2 terms, and you group the last 2 terms, and you try to factor out a common factor from each. By the way, if there's like 6 terms, you can group this 3 and 3. If there's 8 terms, you can group it 4 and 4, but we probably won't get that carried away. So what can we factor out from the first pair? I don't see a coefficient in common, but I do see a t squared. So I could factor out a t squared. And that would leave me with, in order to get the 2t cubed, I'd need a 2 and a t. And in order to get the 5, I'd need a 5. So 2t plus 5. From the second pair, I see a common factor of a 5, but kind of using the same trick or hint that I gave on the previous example, if this middle sign is a negative, factor out a negative number. So factor out negative 5 and ask yourself, okay, negative 5 times what gives me 10t? That'd be 2t. And negative 5 times what would give me 25 plus 5? Negative times positive is negative. Now, factoring by grouping works if when you do that, you see a common binomial factor. If you don't, you can try shuffling the terms around and seeing if that does any better. If you try shuffling the terms in various ways and none of them work, none of them give you a common binomial factor like we see here, then your 4-term polynomial is going to be prime. That means it doesn't factor, using only real numbers. But since we do have a common factor here, we can factor out the 2t plus 5, and you'd be left with a t squared from the first term and a minus 5 from the second term. So 2t plus 5, that looked a little ugly, t squared minus 5. Again, don't get too excited. Before you leave this and say you're done, ask yourself, can either one of these polynomials factor further? They're both 2-term polynomials. The second one looks a little likely because I see a t squared, but it has to be a difference of 2 squares. 5 is not a perfect square. So because it's not a perfect square, there's actually nothing further you can do. This one is done. It is completely factored, and you stop right here. Are you ready for one more? Here we go. So again, when I say now, stop the video, try this, use the recipe page from the first. If it helps, give it a go now. All right, let's see how this works with this. Now, if you try, this is a 3-term polynomial. You don't have to know about perfect square trinomials to factor a trinomial. You could always use trial and error or the AC method. The AC method, if you happen to think about that, you notice you had to multiply 121 times 16. That is no fun. So what I think is best, if you have a trinomial, is first of all see if it happens to be a perfect square trinomial. And here's what you look for. You look to see whether 2 of the terms are perfect squares. Now, the first term, 121, happens to be 11 squared. So I could write this entire term as 11x quantity squared. That's a perfect square. The final term is also a perfect square, and that's pretty obvious. That's going to be 4 squared. So think of the 11x and the 4 as the a and the b that are referenced in the formula for a perfect square trinomial. Now, just because you've got 2 perfect squares, that doesn't guarantee you've got a perfect square trinomial. What's in the middle has to be 2 times whatever your a is times whatever your b is. 2 times the product of these two things that are squared. So let me change colors here. That would mean that that middle term would have to be 2 times 11x times 4. Ooh, right, small, sorry about that. 2 times 11x times 4. Is that true? 2 times 11 is 22, times 4 is 88, and you've got the x. Perfect. Okay? If that had not worked, well, then it's not a perfect square trinomial. But because it is a perfect square trinomial, we use this formula, that if you have something that looks like a squared minus, because of the negative sign, 2ab plus b squared, that will factor. It will factor as a perfect square. And what goes in the parentheses is simply the a and the b. In our case, that would be the 11x minus 4 So there's your A and your B, that entire quantity squared. So I hope this little video was useful and helpful to you as you kind of explore the different methods for factoring polynomials and knowing which one to use when. So go forth from here, look at whatever review homework you've got available to you, give it a try, and see if this helps you feel very, very confident as you get ready for your test. Good luck.